I'm actually going to be talking about one of those AI primitives. I love that term. I never heard it before, but it's perfect. And one of those AI primitives I'm going to talk about is RAG. And I'm going to do so by showing you a project that I recently did called Ask Tom. And guess who this guy is? That's our DevOps team lead, Tom Riley. He's awesome. So what I did is I built, we got all these new policies, which are really cool. And people are always asking me, hey, what does our policy say about this and that? And I don't know. And I don't want to go look. So Ask Tom is the tool I use to ask for me. So first I'll just show you Tom in action here. And it's simple UI. I ask Tom a question. Hey, Tom, what does our policy about backup frequency? So what it's doing is querying our policies using the question I gave it, finding the closest matches to what it thinks is relevant, packaging all of that up along with some special instructions, handing it off to Bedrock and saying, hey, here's the information to base your answer on. Here are the instructions about how to format your answer. Give me a response I can hand back to the user. So then we get a human readable response with references. And then down here, we can actually see the raw results that were passed to Bedrock from which that response was derived. So this is basically Tom. All right, so I'm not going to take time to ask all these questions. You can see how it works. In every case, it's going to give us back a good response, or it'll tell us I couldn't find information about that particular topic. So why I built it, because there's a lot of policies, a lot of information there, questions from auditors, mostly questions internally, and even sometimes my own question to myself. The old way, you would have had to Ctrl+F across a bunch of documents. The new way is to ask Tom in natural language. So here's generally what I described in words in pictures. Your prompt, we're using a vector database to do a semantic search of our policies based on what you're asking. Here are the potential pieces of your policies relevant to the question asked. Package that up, give the question, those search results, and some special instructions to Bedrock, and it chews through it and gives you back an answer. Okay, so RAG itself, I think I spelled it out here. Retrieval-Augmented Generation is what it stands for. Of course, no one says that. But there's three basic steps involved here. The first thing is you have your source data, right? Our policies in this case. You have to break your source data into pieces of information. That's called chunking. In doing this exercise, I came to learn it isn't smart to just take documents and say, break this into 1,000 equal pieces. That's kind of useless. You have to look at the kind of information you're chunking, how it is currently structured, and you have to come up with a smart, what I call chunking strategy. How do I want to break this into pieces that are going to be the most useful and probably relevant for the kinds of questions I'm trying to answer? So you chunk it up. Once you have your chunks, those get converted into vectors, which is just a number, and that's called embedding. And then your final step is retrieval. Your question actually gets converted to a vector first, and then the vector database does a search of your vector and what are my closest matches in my database of vectors. Okay, so a little bit more into chunking. We started with 25 JSON files, which represented our policies. Now there's more than 25 policies. Some of these JSON files contain 2, 3, or 4 individual policies. It's just the way 6clicks exports them. It was not a clean export at all. I didn't have good stuff to work with. But we parse it out, looking at the way it's structured. This was my chunking strategy. All right, it's given it to me in HTML. I can leverage the HTML entities to figure out topics versus content. Broke it into sections, approximately 800 tokens each. There's another AI primitive. What does a token even mean? And the output was 460 searchable chunks. So I thought I'd show you a peek at what a chunk looks like. When it chunks a document, it produces what's called a JSON-L file. The L stands for line, I think, because it puts each individual object on its own line. So each line is a JSON object that represents the chunk. And we'll look at one chunk in detail here. So you have the content, which is the actual raw text. And then part of my chunking strategy was capture some metadata about this chunk. And the reason you want metadata is so you can filter better. So instead of just saying, give me all the information, the chunks that seem relevant to my question, you can say, give me all the chunks that seem relevant to my question, but are also only part of this particular classification of security, or are only in the from the purpose section, for instance. But all this metadata helps you do cleaner searches, more refined searches, and also helps you at the end so you can give good citations of where I got the information. It came from this particular policy, from the purpose section, etc. So that's what a chunk looks like, at least in my case. Now, I haven't chunked a lot of stuff. I haven't chunked any other source data. Well, that's not true, but I haven't looked at the chunks I made. So anyway, I don't know if they all look like this generally, but I know they are JSON-L. So converting those JSON-Ls into math, and 384 dimensional vector each chunk is converted into, and it means so similar meaning, similar vectors. It's a numbers thing. These three pieces of text would all be very similar when converted to vectors. And the particular vector database I'm using right now is ChromaDB, and it automatically does the embedding for me. And yeah. So how it works in the retrieval section, which I've already actually talked about. Let me just show you. I'll do a search real quick. So kind of have this preloaded. But what you're looking at over here is my policy rag project. Each of these are representing my source data from different aspects of the policy set. These are the chunks. And I use Python for this entire project. So I have this script where I can search the vector database and pass it a question. And it's going to give me the top 3 matches. This K3 represents the closest 3. Right, so this is what it returned out of my query set. And you notice it looks a lot like the chunk I showed you. In fact, it is the chunks I showed you. So from a human perspective, this is kind of useless, but it's beautiful data to use to pass to AI. AI loves JSON in the first place. So, all right, that's retrieval. The AI layer, yeah, I've described all this, and we're short on time, so I'm going to skip it. I did use Q to write all of that entirely. I started not knowing at all how it even worked. I had Q explain things to me along the way. It really collaborated well with me. Like, hey, I'm interested in using my policy set as a source of data. How would one go about doing that? We talked about it. Oh, vector database. So we worked our way through it together, but he actually did all the work, but I was the driver of what we were creating. And like Pradeep mentioned, hallucinations, Q can go off on tangents. It can go down rabbit holes it shouldn't. It can try to start doing things for you didn't ask it to do. It's a lot like herding a cat, a really smart cat. But it did all the work. In the end, I didn't write any code at all in any of that. Oh, and of note, it took me about 4 days going from 0 to Ask Tom to get all that done, including the infrastructure, so that when our policies change, I have scripts in place where I can simply recreate the whole vector database based on the new updated information. Oh, and cherry on top, we Dockerized the application so it's easy to deploy. In fact, deploying it is as simple if you use the desktop, pushing play on the container, and then it's running. So if you're doing it from command line, it's you load the Docker image and then you run the Docker image. That's how it works. So it's all self-contained. The vector database is in the Docker container. All the dependencies are in the Docker container. The only thing outside the Docker container are my Bedrock credentials. So I don't have this created really spiffy like Mike does yet, where you don't have to supply your own authentication for this to work. I have to log in myself and then it works for me. But that would be a next step. And show you how I deploy it is really just that Docker container pushing play. That's how I do it. So key takeaways, you're using your own data to answer questions. You're not asking AI to tell you what your policies are, and because you know it doesn't know. You're providing the source information from which it will derive its answers. So you know it's not hallucinating. It's telling you, it's basing it on what you gave it. There's citations for every answer. It's pretty fast. It was fairly easy to build just by talking through it with Q. And it is almost production ready. I'd say it's production ready once I figure out the authentication for Bedrock and do that in a better way, smarter way. So that's what RAG is. You start with a source of data that you would love to ask questions about, and then you build the infrastructure on top of it. So what else could we build? I just wanted to put this here for us to think about, because what I think about a lot is for our product in particular, if someone could ask questions of the product like, hey, where in this application am I able to edit a person's first name? Maybe there's more than one spot, and it could tell you and help you navigate there. That is completely doable. The code base has all the answers in it. And if we find a way to convert that into a proper RAG database or a graph database so that relationships are maintained, easy to answer those kind of questions. And so some future enhancements, I might add more RAG sources like DevOps playbooks, Confluence documentation, and with MCP servers, I can connect to Zendesk and Jira as well. And we don't really have time to discuss anything, but if there are questions right now, I can go ahead and take them. And if not, thank you all for your time and attention.